Chapter 4, which is the last chapter in this course, we are going to look at network infrastructure. After completing this chapter, you're expected to differentiate between simple and complex networks, explain load balancing, identify vulnerable network services, list key features of visual local area networks, name the issue with the simple network management protocol. Due to networks functions and connectivities, there is a need to divide into two. We have the simple networks and complex networks. Simple networks are networks where a single device incorporates all the necessary functions of network. It's usually located, or we usually have them in our small offices or small business and in our home network. For instance, a router that is provided by an internet service provider serves as a simple network to our homes. And the residential gateway is often serving as that router between our home and the internet service provider. One thing for you to keep in mind here is usually the simple networks, they have wireless capability due to the wireless access point that has been built into it. But then it also has security issues because its security is not usually robust like that of the corporate networks. And sometimes they do lack advanced features. And also, due to increased use of smart devices in our homes, like smart fridges, smart doors or locks, smart lights, it has made it very vulnerable for homeowners to likely be attacked by persistent attackers. On the other hand, complex networks consist of enterprise networks, MPLS, and data centers. The enterprise composite network model, it is an advanced network architecture, a model of a complex networks that was introduced to provide a detailed strategy for designing networks in a way that it will become more scalable, flexible, and resilient, which is useful for large organizations with complex network requirements. In this model, the network is divided into three main areas or modules, you can call them. You have the enterprise campus, enterprise edge, and service provider edge. It's important for you to kind of read these three main areas and understand when or how they've been implemented, or where situations or scenarios that they have been implemented or that they do best serve underneath this model. The diagram on figure 4.1 shows us an enterprise composite network model that comprises the three main areas: ISP1, ISP2, frame relay, price edge. Each of these pieces is further divided to define specific distinct functions for the network. Let's look at the enterprise campus. Most important here is its responsibility. The enterprise campus includes the core, distribution, and access layers within the organization's premises. You can see. It's responsible for providing high-speed connectivity and reliable communication between different departments and services. You can see. That's it. Core includes the core and switch blocks. Provide, that's a data center. So the access layer, like I explained. That's the campus backbone. The network management block. Server farm block. The enterprise edge connects the internal network to external networks such as the internet, remote offices, and business partners. You can see it includes modules like the internet connectivity, VPN, and WAN. You could see. So it's more internal. VPN. It's more internal and also helps to connect business partners. So if you have business partners out there that intend to connect using VPN, or employees that are working remote and they want to access sensitive documents, right? They need VPN and WAN and all that stuff. So that's the enterprise edge. Voice over IP, VPN, like I mentioned. Service provider edge, from its name, you can understand its function. It connects the internal network by interfaces with external service providers, various service providers. Cloud networking, because it does include modules like the wide area network and internet service provider connections to be able to do that. You can go ahead and read a little bit of this and be able to understand all this. But most important, you should be able to understand the various three areas in the enterprise composite network model. Their main roles or responsibility, like the enterprise campus, enterprise edge, and service provider edge. Their responsibility would be able to tell you scenarios or situations that they're being used. Keep that in mind. Another complex network here is the cloud networking. Cloud networking or cloud-based networking is when some or all of an enterprise networking resources are hosted in the cloud. It could either be a public or a private cloud. There's another one called hybrid, which you kind of do both, Cloud networking is based on cloud computing, which centralizes computing resources that are shared between users. Cloud networking shares the network in the same way that cloud computing has spurred in a trend in pushing more network functions to the cloud. Cloud networking is just in layman's term is kind of you moving your resources and have a third party take control management of it from a remote location. For instance, you don't want to manage your servers anymore. You don't want to hire you don't want to build infrastructure, hire folks to be on the ground and manage it for you within the business. You rather prefer to get a remote location and have everything transferred onto and be managed. Or for instance, you don't want to be a platform. You don't want to get a hardware and build a platform for you to be getting things done on there, right? You just decide to rent a spot, and for instance, today we have a lot of people getting platforms from Amazon Web Services, and they build stuff on there. A lot of people, renting storage from Amazon, and they're storing the data on there because they don't want to have hardwares within their offices and do it. So that's cloud. So it's being managed from a centralized location, but somewhere, remotely. You can read through this for a better understanding. Secure network design. More than just on the edge and more than just firewalls. Security has to be layered. Has to be a layered approach. Yep, many networks today have industrial processes attached to them. The Purdue model depicts a layered, holistic approach to securing different types and areas of networks. It is a model that sides with what is called a defense in-depth model, where deeper in the network, more restrictive, less access, zero trust features are enabled. Zero trust or defense in-depth approach is kind of, there's a control at every layer. Every layer there is a control. It's like, for instance, the fact that somebody has access to your main gate doesn't mean that they're just gonna get into home and be able to access every door. Like, every door has an access code. They're gonna be granted access in every area, irrespective if they had access granted in the main entrance. That's what defense in depth is all about. Talk about the enterprise edge. In the enterprise composite network model, the DMZ is very important, and authentication is also very important, because the enterprise edge area connects and provide access to external networks and for remote offices and business partners. So this is very important. You can read all this for a better understanding of how these players are involved when it comes to security, AAA for authentication and all. So you can read all that. Read it for a better understanding. Get a better understanding of what DHCP snooping is all about and what IP source guide is all about. Read that. It's self-explanatory. Figure 4.4 shows an IP traffic security filtering. In the previous chapters, we talked about how packets look like, headers and all that stuff. So when it comes to traffic security filtering, those are the things they're looking at in the frame, those headers, the source IP address filter, the source IP and MAC address filters, so you can read that for better understanding. Dynamic RP inspection. Read it and be able to understand what it does, right? It just prevents a generation protocol spoofing and poisoning, so and it helps when it comes to security. Private VLANs. It helps when it comes to prevent security implementations. Read that for a better understanding. Please do. Remote access. During COVID, prior to COVID, there's a lot of remote access companies working with external partners. But during COVID, it became very common. Then we had another group of teleworkers, which defined most of our business models today. So you might want to read this and have a better understanding about enterprise teleworkers. The business goals and requirements and some of the issues or challenges in read. It's important for you to know that. Network visualization. It's important for you to read and understand considerations for implementation of VLANs. Understand end-to-end VLANs. The features, its features, geographic dispersal. Membership users can be grouped into VLANs, yep, regardless of the physical location. We talked about that in the previous chapter, where due to its capability, a single switch, departments, and separate floors in the building can be able to leverage VLAN on the switch. Local VLANs. Directory services. You can just read this for a better understanding of this course. Network operations. Network configuration management. From its name, you can just understand that it's just for the organization and management of computer network. That's all what it's all about. Well, in this case, administrators are involved to access the network, repair, make modifications, do troubleshootings, and assist the business with quick resolution to network issues. So, SNP. What you have to keep in mind in relation to SNPs is just that it's a network management protocol used basically for exchanging management information between network devices. You can see here it says can be used to retrieve information from a network device, commonly referred to as read-only access, or to remotely configure parameters on the device. For instance, configure a router or check the status of a router. If in your labs, you may probably be assessed on how to send commands to check the status of a connection to a router functionality of a device. So keep that in mind. These are recommendations to kind of correct use of SMP tools. Network device management, from its name, right? Manage a device that's on the network. For instance, when a new device network is installed or an equipment refresh is completed, all related network documentation must be updated. So, for instance, total number of devices, device models and names, address for each device, support or warranty information for each device, spare parts and devices. So it's just basically, updating. So updating when the new network is built. Yep, just updating. One of the things that you need to understand with network device management is S&P plays a huge role to gather and monitor those devices. It gets the information and monitors the devices and provide that information in this process. There are a bunch of protocols that are available when it comes to network management functions. All you need to know is just what those various protocols are responsible for. For instance, we've got the TFTP, which stands for Trivial File Transfer Protocol. It's used for transferring configuration or system files across the network. That's it. And it does uses a UDP to do that. Technically, it's not secure, but it can be made secured. All you need to do is just to be able to encrypt that data while in transit by using IPsec. NTP, Network Time Protocol. It is used to synchronize the clocks of various devices across the network. That's its role. How important is it? It's very important when it comes to digital certificates or for interpretation of events within system locked data. So, for instance, if an active attacker, persistent attacker, gets into your system and change files and then go to kind of modify the system lock, right? You could pretty much go by and look at the timer and says, hey, this is the time of the device. It doesn't really sync, somebody might have tampered with. That's how important network time protocol is. It does allows administrators to implement master clocks to satellite or radio to coordinate universal time. So that just resonate to what I explained. Just like every system, right? Once you build a new network, one of the things you want to be sure is to test and ensure that all the features are working correctly. That the amount of data that has to do with that is involved in the transportation is flowing correctly. and that the speed that was its expected speed is up to the task, and all the devices are communicating. So identity and access management, I think we already touched that a little bit up, and but anyway, we're just gonna dive into it again. The AAA stands for Authentication, Authorization, and Accounting. Authentication, Authorization, and Accounting. When we talk about authentication, right, it requires a user and administrator to prove they're really who they are, who they say they are. For instance, when you're logging into a system, they're going to ask you for your username and they're going to ask you for your password. So, and once you put those details right, a response, which is kind of like a token and cats and other tokens and cats and other methods, are kind of like another way too for you to prove. Let's say you have a workplace issued badge and you walk to the door and you want to go in, right? You can use your access card, to kind of swap, so they can grant you access. That's another way of kind of like logging your username and password on a portal. Authorization in this case has to do with the background work, right? Once you've logged in your username and password, or you've probably swapped your badge, right? The service will decide what level of access you do have. That card that was issued to you doesn't really give you access to all the other doors, right? And the fact that you access a portal doesn't mean that you have access to all the features that's in that system. So that's what authorization is all about. It determines the services that are available to you, that you're able to allow to access. Like I said, assigning perimeters when it comes to internet or network connectivity, right? It's about assigning parameters such as IP addresses and access control list. For instance, it's not all devices that are able to tunnel through certain areas, or it's not all users whose accesses are able to grant them access to some remote locations where data is being housed within a corporation. Accounting, it's the last but most important piece, right? From its word, accounting is kind of like transparency. Accounting records what the user and administrator actually did. So we talk about that syslog, system log. So every time you log into a system, whatever you do, right, it just keeps a record of what you did. That's what accounting is all about. It's important for auditing purposes. Here says AA has two primary purposes: authenticate remote users attempting access to the enterprise network, and authenticating administrators attempting to access the router console. So the diagram on figure 4.5 shows an AAA service implementation. Like I said, right, that's a service provider. Let's say this is Verizon, and you've got a VPN, right, that tunnels through. You've got a network attached storage, NAS. You've got other components as a control service. You've got the modem, that's the internal network, and that's the firewall, right? When it comes to authentication, Radius and TACAX Plus are the two main protocols that are involved. Radius It's a standard-based protocol that was created by the Internet Engineering Task Force. It was proprietary to Cisco Systems technology. However, today it's open. It's mostly an open standard, supporting most major vendor equipment. It provides many benefits for configuring devices to use the AAA for management and terminal services. It can control the authorization level of users. On the other hand, radios cannot. TACACS Plus separates authentication and authorization. It is possible to be used for authorization accounting while using another method of authentication such as Kerberos. RADIUS stands for Remote Authentication Dial-In User Service and commonly used by Internet service providers, cellular providers, and enterprise networks. As an AA protocol, it serves three primary functions. It does authenticate users or devices before granting network access, authorizes users or device to specific services, and accounts for service usage. A key takeaway between radios and TACACS is the differences, right? TACACS began as a proprietary Cisco system technology, though it's been mostly open standard, supporting most major vendor equipment in today's world. However, the difference between TACACS and radios is TACACS encrypts data. It runs in TCP, whereas radios operates in UDP. Keep that in mind in case you come across this in the exam or at some point in time, or maybe wherever you get tested on this. So. Diagram in figure 4.6 depicts a client device that's trying to connect to a network. Is a step-by-step, shows a step-by-step process of a client device trying to connect to a network. That's it. Client sends a request. Router prompts client for a username. Client provides a username. Router prompts client for a password. Client provides a password. Router then forwards username and password to radius server using an access request diagram which contains the necessary attribute pairs. So it's definitely going to take those details and go and check in the database and see if that is the person that says they are. And if we do have them on our list, whitelisted. If that information is correct, server responds with an access accept datagram. Yep. So that's the process. The table in figure 4.7 lists the 4 radios message types, their description. You've got an access request, you've got an access challenge, access accept or access reject. You should understand that the TACACS Plus provides a lot more flexibility than radius. Yep, we've seen that because you can go with Kerberos. TACACS is the primary protocol for AA implementation that is supported on routers, switches, and firewalls for Cisco. Keep that in mind. It's more flexible than radius. uses TCP. We've talked about that. The diagram of figure 4.8 shows the authentication process using the TACAX protocol. It's similar to Raiders that we just seen, right? But now in this case, a client is trying to access the Dubai branch office, but the router will be communicating to an AA server that is running TACAX Plus. Based on the diagram here, right? Here what happens, client sends request to access, router requests a username prompt from the TACAX Plus server. The TACAX server provides a username prompt. So instead of the server reaching out, is a router that sends it, and then the server sends it back. The router prompts the client, then the router takes it and reach out to the client. The client provides the username. The router forwards the username to the server. The router requests the password prompt from the server, and then the server provides a password prompt. The router prompts the client for a password. The client submits the password. The router forwards the password to the server. The server accepts or rejects the user. So in this case, the router is technically working more of heavy duty, like a middleman is doing the stuff. Those are the 4 messages. Diagram of figure 4.9 shows examples of TACAX Plus attributes that are frequently used for authentication authorization, listed here. You can read this for better understanding of this course. Network performance. When it comes to load balancing and redundancy protocol, the takeaway here is just to kind of understand what load balancing is all about and what redundancy protocol means. So I'll go straight to the point. When it comes to load balancers allow for many more requests and responses to a server than a single server could handle. And this is what happens. So the ability of many web servers are set up. Many web servers are set up with the same website. And as traffic comes to the website address, a load balancer is kind of like a robot you put in place, right, to measure how much traffic is coming, what they're looking for, right? So that's what a load balancer is all about. A load balancer is placed in between the internet connection and the web servers. It controls that request and makes sure that they are evenly distributed across the web servers. For instance, let's say you're renting out a car and you realize that your clients or people have taste for Mustangs. Instead of putting out 1 Mustang for rental, you can have 6 Mustangs. And as people's requests do come in, you're evaluating the request and dishing it out as to the locations, to your rental locations where you have those Mustangs. So the person that is sitting in between and looking at those rental requests, looking at the kind of cars that they're asking for, and routing those people's applications to the available car rental locations that have that similar car, to play the role of a load balancer. But if you don't have somebody that will be looking at those applications early on and routing them to where they have enough of what they're asking for, then we're going to end up having people's applications rejected if they keep going to a particular car rental location asking for the same thing, whereas they've already rented it out to somebody. So that's what load balancing is all about, for better understanding. Because if so many people kind of try to access that same website, it's going to crash. Or requests will get rejected because they can't meet up with the capacity. With GLBP, which is Gateway Load Balancing Protocol, for your understanding, it just basically provides a working example of load balancing protocol. That's what it does. It does allow for automatic selection and simultaneous use of all available gateways in the group. You can rate this for a better understanding. But what is very important is just to kind of understand the concept of load balancing. Load balancing. The diagram on figure 4.10 shows the GLBP, a gateway load balancing protocol. You've seen this, right? That's port 1, port 2. And you've got clients they're trying to access. Quality of service for voice. The key takeaway here is it just basically gives an administrator the ability to be able to use control features to manage specific types of traffic. Especially those traffic that are sensitive to loss, delay, or delay variations. For instance, manufacturing companies, they have folks that deal with just quality. So that's basically what this guy does. All this services does when it comes to network quality of service. Quality tester. Ensure when traffic is going south, they jump in, examine it, and try to correct it. Classification. Classifications identify specific traffic for use later in the network for prioritization or other control of the traffic. Figure 4.11, classification by layer. Yep, network traffic. When we talk about networking, we're talking about traffic, packages, frames. So classification, layer 2 information, those are the things that are involved. Layer 3. You can read all these various concepts just to get a better understanding of this course. 4.12, marking traffic. So we've seen here that markings, when traffic has been classified, they mark the traffic to allow other devices in the network to handle the traffic the way it is specified. Yep. Network monitoring and reporting. Talk about the syslog protocol, right? It just logs data. When you access, what you did, Just giving information for accounting purposes, for auditing purposes. You can read that for better understanding. System hardening. The table in figure 4.13 contains a listing of the most vulnerable and most commonly attacked services and processes. Yep, keep all this in mind. It's important for you to know the vulnerable items that needs to be secured. Open router interfaces. It is vulnerable. So you have to think about ways in which that can be secured. What does it do? It limits unauthorized access to the router and the network by disabling unused open router interfaces. Therefore, if you have an interface that is not in use, disable it. The boot P server. Yep. It's always enabled by default and rarely required. So disable it. Cisco Discovery Protocol. Enabled by default. Disable it, please. So just kind of read this and kind of understand what state those ports, those what state those services or processes are at the time of factory default. They usually, when they talk about vulnerable, means by default, by factory default, they are always enabled and rarely being used. So keep in mind those processes or systems that by default and some too by default are disabled. But the bottom line is the default state of that device, whether it's enabled or disabled, puts the life of the system or the system, the network system, at risk. Like in this case, the TCP keep alives is disabled by default. But how does it put the network system at risk? It's very simple. The role of the TCP keeps alive is to manage TCP connections and prevent certain DOS attacks, denial of services attacks. But if it's disabled, then it's not going to be able to do that, and then the system is prone for DOS attacks. But the other services that are enabled by default, which is risky, for instance, the ICMP, unreachable notifications, this service is enabled by default. What does this service do? It's meant to provide an information. So this information can be used to map networks and should be disabled. Here, for instance, you don't want an attacker or somebody or your neighbor to kind of have an understanding how your house is set up, because that is your secret recipe. If they understand how you do things internally, it makes you vulnerable. So you don't want to give that information out there. So read through this and get yourself acquainted with what the default state of these services or processes are and what action should be taken. Command line interface based auto secure. You can read it. Lockdown items. Read it for better understanding of this course, please. We have definitely come to the conclusion of this chapter and the end of this course with a knowledge check. Please, when you read through or when you review this book, do not hesitate to look a little bit deeper into the areas that I lay emphasis on.